So in the first row, each of these problems is basically the same. They're one-step equations. So we need to find our variable and decide if there's anything being added to or subtracted from it. So here's your variable. There's a 4 being added to it. We need to do the opposite. The opposite of adding 4 is subtracting 4. Make sure you do the same thing on each side. And we know what to do because we're doing the opposite of what was being added. So since 4 was being added, we have to subtract 4 from both sides. This leaves us with x on the left. And on the right side, 7 minus 4 is 3. And that is the answer. Now if we were to substitute this back, we can see that 3 plus 4 is 7. And 7 is equal to 7. That's how we know we are right. On the next one, there's our variable. We have the a. There is negative 5 being added to it. So we need to add the opposite. The opposite of negative 5 is positive 5. We're going to do the same thing on both sides of the equal sign. The a comes down because this eliminated. It made 0. On the right, negative 9 plus 5 is negative 4. Now if we go back and substitute negative 4 here, negative 4 plus negative 5 is negative 9. So that's how we know we're correct. In this problem, this is the same as x plus 16. So don't let it fool you that it's in the front. Because there's no sign here, we can assume correctly that it's positive, which means we're going to do the opposite and subtract 16 from both sides. That makes 0. We're only left with x. Negative 34 plus negative 16 is negative 50. Right? So if you start at 0 and you go to the left 34, and you go to the left 16 more, you're going to end up in the negative. So some of you had the right process, but you were doing the math incorrectly. So be careful with those integer operations. Okay? All right, so that was the first row. For the first one, again, we're looking for our variable. There is a negative 8 here, so we're going to do the opposite. The opposite of negative 8 is positive 8. Remember to do it once on each side of that equal sign. There's your 0. Bring down the x. 14 and 8 is 22. If we were to plug it back in, if we were to substitute it for x, negative 8 plus 22 is 14. So we're right. For the next one, remember when we're subtracting integers, we say that we're going to add the opposite. So m minus negative 10 is same as saying m plus 10. Oops. M plus 10. From here you can see we need to do the opposite, the inverse operation. Here's our 0. We're left with m. I don't know why it keeps moving. And negative 20 plus negative 10 is negative 30. And there's your answer. Now if we were to substitute it back, excuse me, negative 30 plus 10 is negative 20. All right, so this one gets a little bit different. So here we have our variable, and what's happening is that it's being divided by negative 5. The opposite of dividing, or what we say with our math vocabulary, the inverse operation. The inverse of dividing is multiplying. So to solve this, we have to multiply both sides by negative 5. Okay? So on this side, think of it this way. You're multiplying negative 5 times x over negative 5. These cancel out. Because if you multiplied straight across, you'd have negative 5 over negative 5. And any number divided by itself is 1. So this equals 1x, or we can just call it x. Okay? But I digress. We still have to solve this one part here, because we have the x by itself. I'll bring it down here. So 1.2 times negative 5, I know it's going to be negative because I only have one negative sign. Let's see, 5 times 12 is 60. So 5 times 1.2, or 1 2/10, is going to have to be negative 6. And that's your answer. Now if we were to substitute it back, negative 6 divided by negative 5 is 1.2. So we're right. Again, we would look for our variable. This is being divided by -4. The opposite of dividing by -4 is or it's not negative. Where did I get that from? Sorry. The opposite of dividing by 4 is multiplying by 4. So we're going to multiply by 4 on both sides. These cancel out. We get x. -2.5 times 4. Well, I know my answer is negative because I only have the one negative sign here, right? Let's see, 2.5 times 4. Well, I know that 2.5 times 2 is 5, and 5 times 2 is 10. So my answer is -10. If we substitute it back, -10 divided by 4 is going to be -2.5. So there you go. For the next one, again, see, it's the same thing every time, isn't it? There's your variable. It's being divided by 2. The inverse of dividing by 2 is multiplying by 2. These cancel out. We get n. -22 times 2. There's only one negative sign, so my answer is negative. And 22 times 2, well, multiplying by 2 is just doubling your number. So 22 times 2 is 44. So n is -44. So if we substitute it back, -44 divided by 2 is -22. So that's how we know we're right. All right, this one's a little bit different. On this one, we have 1/3 being multiplied by z. And did you know that 1/3 times z, we don't know what z is, but I know we could put it over 1. If we multiply it across, we get z thirds. So this is the same as z thirds. Okay, so from here you would do the same as you did above. But let me show you what you could do if you wanted to leave it as 1/3, because there might be a time soon where it's not going to be a 1 in the numerator. So what you would do technically is, because the z, your variable, is being multiplied by 1/3, the inverse of multiplication is division. So instead of multiplying by 1/3, you would say we're going to divide by 1/3. But when we divide by fractions, when you divide with fractions, do you remember what we say we have to do? I bet you know. Yep, you have to multiply by the reciprocal. And oops, I can't spell and talk, by the reciprocal. And a reciprocal is just the number you multiply by to equal 1. So the reciprocal of 2/3 would be 3/2, because when you multiply them together, you get 6/6. When you divide, you get 1. So in the example up here, instead of dividing by 1/3, we're going to multiply by the reciprocal. So we're going to multiply by 3/1 times 3/1. Give me my denominator there. These are going to cancel out. So you're going to end up with z. And over here, we're going to multiply straight across. -5 times 3 is -15. Right? When we multiply fractions, we go straight across. 1 times 1 is 1. And -15/1 is just -15. So that's your answer. Now, if we were to plug it back in, or substitute, as we say with our math vocabulary, if we were to substitute -15 times 1/3, well, that's the same as saying -15 divided by 3, which is -5. So that's how we know we're right. For this one, again, we look for a variable. It's being multiplied by -1/4. So the inverse of multiplication is division. But when we divide by a fraction, we multiply by the reciprocal. Notice I did not forget my negative sign, did I? Yep, that's important too. So that cancels out. We have x. On the right side, remember that when we multiply fractions, we multiply straight across. So 5 times -4 is -20. 2 times 1 is 2. And to simplify, we divide. -20 divided by 2 is -10. So x is -10. If we substitute it, we know that -10, we go here, -10 times -1/4 would be +10/4. And if you divide these both by 2, you get 5/2, which is what we started with. So we did it correctly. Next one. Again, there's your variable. We want to get it by itself. It's being multiplied by 2/3. We're going to do the reciprocal, or multiply by the reciprocal, because that is how you divide fractions. These cancel out. We have x. In this one, we're going to multiply across. 3 times -4 is -12. 2 times 1 is 2. And -12 divided by 2 is -6. So that is our answer here. If we substitute it back, -6 times 2/3, right? So -6 times 2/3, that's going to be -12 over 3. And if, oh, okay, I almost confused myself. -12 divided by 3 is -4, which is what we started with. I'm used to having my variable on the right, so I was checking my answer, and I saw 2/3. I was like, wait, what? But no, we had the variable on the right. And it doesn't matter if your variable is on the right or the left. Traditionally, I just prefer my variable on the left, but it really doesn't matter because it's an equal sign. It's showing equality. One side is equal to the other, so it really doesn't matter which is on which side. Okay. The last one. 3 is being multiplied by b. Here's your variable. This is what we want to get by itself. It's being multiplied by 3. The inverse is dividing by 3. But because we have a fraction, we're going to have to, who knows it? I know you know it. Multiply by the reciprocal. Oops. Multiply by the reciprocal. So we're dividing by 3. The reciprocal of 3 is 1/3. So those cancel out. There's your variable. Multiply across. 2 times 1 is 2. 3 times 3 is 9. So b is equal to 2/9. If we multiply that by 3, 2/9 times 3, you know, if we were going to substitute to check our answer, 3 over 1 times 2/9. Remember, we go straight across. 3 times 2 is 6. 1 times 9 is 9. And if we were to simplify, it has a common factor of 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And there's our, where we started. So we did it correctly. 2/9 is the right answer. Second step. Oops. Okay, so now we're moving on to two-step equations. They're called two-step equations because you have to do two things. So here's our variable. First, we have to undo the addition. Do you remember the lesson where the first thing said, is there anything being added or subtracted? And we'd have to do the inverse. And then, that was step 1. And then step 2, you had to undo the multiplication or division. Yep, it's the same thing. So here, I'm going to subtract 3 from both sides because there's my 0. We're left with 2x. -7 minus 3 is -10. Yeah, so be careful with this integer operations, okay? Finally, here's our second step. 2 is being multiplied by x. The inverse is to divide by 2, because the opposite of multiplying is dividing. 2's cancel out, and x is equal to -5. And we can substitute. We can put it back in here. 2 times -5 is -10, and -10 plus 3 is -7. We did it correctly. Over here, here's our variable. We already have something being added to that variable term. It's the -5. So we're going to do the opposite. The opposite of subtracting 5 or having a -5 is adding 5. Notice that I'm doing it once on each side of the equal sign. Right? There's your 0. That's gone. So we're down to 6a is equal to 19 and 5 is 24. Again, here's your variable. We want to get it alone. It's being multiplied by 6. The inverse of multiplying by 6 is dividing by 6. The 6's cancel out, and we're left with a is equal to 4, because 24 divided by 6 is 4. And that is your final answer. Now, if you want to substitute it back in to check, let's see, we have -5 plus 6 times 4 is supposed to be 19. We had to multiply first, you know, order of operations. 6 times 4 is 24. And look at that. -5 and 24 is 19. Those are correct. Last, guess what? We're going to do the same thing. There's your variable. We've got minus 2 next to that variable, so we're going to do the opposite and add 2. Make sure you're on both sides of that equal sign. This makes 0, so you're left with 9x is equal to 27. Because 9 is being multiplied by x, we have to do the inverse, which is to divide by 9. That cancels out. This x is 3. And there's your answer, because 27 divided by 9 is 3. So if we substitute it back in, 9 times 3 is 27, minus 2 is 25. So that's how we know we did it correctly. All right, big surprise, we got to find the variable. First, we're looking to see if anything is being added or subtracted, so we'll undo that first, and then we look to see if anything is being multiplied or divided. So here, I see we have -4. We need to do the opposite to both sides of the equal sign. That cancels out. You're left with 1/4 x is equal to -6. Yep, be careful with those negatives in your operations. And now, I can see 1/4 is being multiplied by x, so we're going to do multiplying by the reciprocal. These cancel out. We're left with x is equal to, and then -6 times 4 is -24. All right, we don't have to worry about that denominator of 1, do we? No, we don't. All right, moving on. Next, here's our variable. We have something being added, so we're going to do the opposite to both sides of the equal sign. There's your 0. 2/7 y is equal to 3. Because 2/7 is being multiplied by y, we need to divide by 2/7. But when we divide fractions, we multiply by the reciprocal. Let me give that denominator of 1 to help us. These cancel out. We get y is equal to, let's see, 3. Remember, we go across. 3 times 7 is 21. 1 times 2 is 2. So for our answer, we have 21/2, which if we wanted to divide that to get a decimal, let's see, well, half of 20 is 10, and then half of 1 is a half. So there's that one. And then, let's look at the final one. I feel like I made a mistake on that one. Oh, hold on. Subtract 12, you get 3 times 7 halves. I covered the problem, right? Yep. I guess a lot of people didn't pick that one. Remember, on your original, you only had to do 1 from each row. So I guess a lot of people didn't pick that one. Anywho, here's our variable. I notice that we have this -3 over here, so we need to move that to the other side. Because we're always trying to get x by itself, which we call isolating the variable. There's your 0. We're left with -1/4 x is equal to 9 and 3 is 12. Because -1/4 is being multiplied by x, we have to divide by -1/4, but we know that means multiplying by the reciprocal. So that these cancel out. We get x is equal to negative, right? Because there's only one negative, and 12 times 4 is 48. And that's your answer. Okay, if we put it back in, -48 times -1/4 is going to be +12, and -3 and 12 is 9. So yep, we did that one correctly too. Okay, here's our variable. This time they used the m. I notice there's a -5 here that's being added to that term, so we're going to do the inverse operation, or the opposite, which is to add 5. There's your 0. So we have 30 is equal to 2/3 m. Because 2/3 is being multiplied by m, we need to do the opposite, or the inverse, which is dividing by 2/3. But when we divide fractions, we have to multiply by the reciprocal. So if I were to multiply, I'll do it over here, 3/2 times 30. I'm going to give 30 the denominator of 1. And we multiply fractions, we go straight across. 3 times 30 is 90, and 2 times 1 is 2. Finally, we divide, that's what the fraction bar tells us, and 90 divided by 2 is 45. So, that means that 45 is your answer for this one. Next, here's your variable. This is what's being added. There's a -3 being added, so we need to do the opposite. Let's add 3 to both sides. Right? Remember, both sides of the equal sign. Here's your 0, so that's gone. So I'm left with 7/3 x is equal to 4 plus 3 is 7. 7/3 is being multiplied by x. We have to do the opposite, or the inverse, which is to divide by 7/3. But when we divide fractions, we multiply by the reciprocal. This is a fun one. Look at this one. So 7/1 times 3/7. When we multiply fractions, we go straight across. 21/7. And 21 divided by 7 is 3. So that means x is equal to 3. There's your answer. Last one for this side. Here's my variable. This is what's being added to the term. So there's a -3, so I need to do the opposite and add 3 to both sides of the equal sign. 5 and 3 is 8. There's your 0. I'm left with -1/9x. The -1/9 x is being multiplied by the variable, so we have to divide by -1/9. But when we divide by fractions, we multiply by the reciprocal. Notice I'm including that negative. All right, these cancel out. You're left with x. -9, over 1 times 8/1 is -72. We don't need the denominator of 1. We'll leave that. So our answer is -72. So we learned when we were taking notes that when you have a denominator like this with an expression in the numerator, you have to assume that there are parentheses in the numerator. So what we have to do first is get rid of the denominator. So in this one, I can see that the expression is being divided by 2. So the inverse of dividing by 2 is multiplying by 2. These are going to cancel out. You're left with x plus 3 is equal to, and over here when we go straight across, 5 times 2 is 10, 2 times 1 is 2, and 10 divided by 2 is 5. So now we have x plus 3 equals 5. Well, now this looks a lot like what we did in the beginning. This is just a one-step operation, a one-step equation. There's your variable, and there's the plus 3. You're going to do the opposite, or the inverse operation. There's your 0. You're left with x equals 5 minus 3 is 2. There's your answer. Let's try it again. In this one, it's being divided by -7, so we're going to do the inverse and multiply by -7. -7 times 6, that's -42. These cancel out, so you're left with -5 plus y. Again, there's your variable. There's a -5. Let's do the inverse operation. Remember to do it once on each side. There's your 0. You're left with y on the right. -42 and a +5 is going to be -37, and that's your answer. -37. Moving on. And we can substitute. I know I keep skipping that step. So if we put a -37 here, I know that -37 and -5 is going to be -42, and -42 divided by -7 is +6. All right, last one. Where did it go? Oh, I just skipped the first one. My bad. I was moving my screen. I learned how to move the screen. Okay, so here we have the 3 in the denominator. Remember, we're going to get rid of the denominator first. And because this is showing me it's being divided by 3, the inverse is to multiply by 3. These cancel out. We're left with m plus 7 is equal to -15. There's my variable. I have a plus 7, so let's do the inverse operation, which is to subtract 7. Now it moves when I don't want it to. These add to 0, so you're left with m. -15 and -7 is -22. That is your final answer. And that's the end of the worksheet, my friends. Good job. I hope that going over these 22 problems was helpful. I mean 24. Yes, I can multiply. All right, that's it.